Now in this video too, I'll talk to you about things to consider at the level of all. The construction tree for the creation of an intermediate part, therefore, that is interconnected with other parts, so purchased items or parts that you have already drawn. This obviously has an impact directly on the design of your room. Have to take into account the three geometries, the parts that interact with your room. Gives a construction tree like this with usually an assembly for parts that come from the outside, and then we have a building tree with the file of your room, a body, a sub-object shape binder that is a ghost of external parts to consider for your construction. And then in fact we're really moving on to construction, so that's a very important element. It's important to consider if you're making these kinds of coins. So now we're attacking the second one. So it's going to be a piece that's going to glue between elements that come from. So a typical example is if you have to make a small case for electronics. So you're going to buy standard items on the market and you're going to build around these here. So the items you buy, it's a constraint, they're like that. You have to build with their geometry in mind. You're not going to adapt them to. So what you need to do is integrate them into your construction. So how's it going in general? 3D that will be provided by the component provider or on a site like GrabCAD, and you go make a first assembly. In fact, with us simply dispose in your file the items that you're going to use it. And then you're actually going to base your construction on these prepositioned elements. So we're going to see this right there right now. So we're going to start directly by creating a file. This one we're going to put directly in the right place. Workflow. So intermediate piece. What I do in general, I make a piece. A file that I call design. So it's a file in which I'm going to import the 3D that I have to integrate into my construction. So I was telling you this is no link, no interest in this GrabCAD platform. This is an example where you find plenty of 3D actually for standard parts. For example, a 3D printer engine. So it's very convenient actually. You can download. So it's never in FreeCAD, but there are always step files that you can bring in, almost never in FreeCAD. But there are always step files that can be used very well in fact, which are the standard exchange format between the different CAD. So then you select the item you like. You have the little list. Well, that's a bad example, where there is only the SolidWorks file. But we're going to look at this one here. Well, there's only the step file where you can download it. And then you have your 3D. So it's very convenient. So here I'm going to introduce you to the case. I'm going to simulate the case of creating an electronic enclosure. So I've already downloaded 3 small electronic components. So we're actually going to integrate that into our designs. So for that, I'm not going to use it. In fact, there would be 2 possibilities. Or you can import it directly like that. So I took the Raspberry Pi Pico for example. It takes a little time, e-cards are a lot of stuff on them, so sometimes it's a bit hard to import. So this is my little element, so there are several ways to do it. You can either do it just like that, so this is a small screen, so it's all about each other. Then you can actually, if you don't want to do assembly, in fact you can just import them like that. And then here, so you see, they're made up of different elements. It imported them as parts, composed themselves of different parts, composed themselves of bodies. So you can, if you want to move the set in fact, you make right button, transform, and then you can just. So this is my little Raspberry Pico. So I'd like to have my screen there on top of my case. It's not in the same place as my little microcontroller. We're going to put this here, so you can just navigate and position it a little bit. A little bit like that, the one again, it's something quite possible. I wanted to integrate a little encoder, that's it, so it's important again in the middle. Same operation, we move it where we want it, so it's really a plot design. But it's very practical in a first approach to work like this. So that's a way to do it, just position it like that. We're going to do something a little bit more correct. We're going to do this, but with the assembly workshops. So the second method, so we record this second method. It's about making an assembly, so now as standard you've got the assembly shop, which comes directly with this one, which comes directly with the installation of FreeCAD. He's not bad, but there's still a lot of kids, and I think he's in my opinion. Now, on my different years of experience, he's not quite mature yet. I suggest you also take a look at the A2 Plus workshop, which you can install via the add-on manager, which is almost a little simpler in my opinion, for a beginner, because it is very regulatory. So here you can import directly your step files. That's it. They appear there in the building tree. So this is the screen. I'll make a more detailed video later. Compare these two assembly workshops. What can we do with one? What can we do with the other one? The new assembly shop is very good. It's going in the right direction to do many things. The A2 Plus workshop he's really very good at it. So here, we're gonna do something very simple. Actually, I do. Constraint actually my 3 electronic turntables actually in the same plan. So I'm just going select that surface there with this one, and then after that, they say here, that coincides with it. There you go. It's on the same level. Okay. And the same here. That coincides with it. There you go. That's enough. So, if we look carefully, it makes it possible to align the faces at once. Faces. That's the face. With this one. And then after that, they say here, that coincides with it. There you go. It's on the same level. There you go. Exactly. In the same plan. You're sure? It's not done. Pretty much. Here. I did. Pretty much. In the example before, positioning with him, the tool transforms. That's pretty much it. Okay? But it's pretty much. Here. It's in the same plan. There you go. So, it's the two ways of doing things. Depends on what you want to do. So now, we did both of us, our 2 design files, and then we're going to go over there. The most interesting part, that's why. It's here. The creation of the housing. Around alt of these 2 elements. Actually, so, it's 3 elements. Even so. How's it going? That's why. We're coming back now. Sure. There. The main question. From this video. Workflow. So here. Let's go. Press start. Construction. From our bodies. On it. Sure. One of his assemblages. So. How's it going? So. There are several possibilities. You can either create the body directly within the file after it's getting a little borderlick. Me. I think so, that it's more square. Actually, to create a new file, let's go, named, actually, enclosure. There you go. We're coming back with it. The workshop. By design. So, there. It's like the room alone. Actually, we have another file. And then, that's all. And then, there. We have our assemblages. Behind. That's what we do. There. Let's book. So, we're going to our box. And then, there. We have our assemblages. Behind. That's what we do. That's what we do. There. Let's book. So, we're going to our box. We're gonna create the body. That's why. F2. We're calling him box dot. Box dot. There you go. Touching. And then, now, instead of, to support our construction. On the marker, who's back there, we're going to use an element, external. So, how's it going? You're on the file. You're interested to show this right. Actually, I'm going to put this on like this. So, the first, we're removing it. Here, we're going to shut this down. And then, we're doing it again. Cascade. There you go. This. You see? It's okay. So, we've got ours. File. Enclosure. There. With the little body. And we're gonna use it. Actually, ours. Elements. Standard. Like. Base. For starters. Or our construction. So, there. We're gonna use it. Actually, ours. Elements. Standard. Like. Base. For dot part. Our construction. So, there. We're gonna use it. The 3. And then, after, you click dot there. Sure. There. Not bad elements. So, this calculating 1 kid. Not much. This has not created. There. Alright. File. Actually. Let's go. Delete. There. So. You. Select. Your file. So. That's it. Very important. To be in the put it on your elements. D. New references. And after. That's why you select the no and you create this. There you go. And that's why you find it in mind. Done. 1 tween. There. We got it. This. 1 2. Op wo. Gleich. 1 1 1 1. A species. D. 1 1 1. To be able to actually use these ghost elements, in fact, to make your construction, you will Be able to lean on it so you can hide the marker, and then you can say now. I'm building there on this face, there select this face there, and you're doing a sketch. And here we go, we're going to make a poor rectangle to the eye like that. Just there, we'd like the screen to get out of the box, so we'll use it. We're going to create external elements in our sketch in wired mode. And we're going to put a rectangle around our screen. Which will actually prevent the creation of the volume within the sketch. I may have lost you a little bit. It's an African convention, actually. If I had kept this sketch here, it would create a complete rectangle and add the rectangle in the middle. There's going to be a hole directly for the screen, so I'll show you all. Right now I'm going to do my sketch and hope I'm doing my extrusion. And here you see, it's on right around, so I'm going to make a very thin 3mm thick case. That's enough, so there is. There will be my screen. There we validated and our shape in there. It disappeared, we can make it reappear. It remained in E. Wired, we go back to classic mode here. My encoder, we see it's going a little bit beyond. So it's not necessarily ideal as I had aligned it, so we're going to change it a bit. So here's the thing. The detail I haven't told you about, you can actually at the shaper-binder level define if it is synchronized with the reference elements to which it is there or not there. As standard, it is synchronized. It means that if I move my encoder, it'll actually update my shaper-binder. We're here to test this, so I'm going back to my design assembly here at the level of the encoder. I have a constraint that I'm going to remove here, and then we're going to do something very simple, is that we're going to move it with the tool transforms. Directly along the z-axis, so that the encoder is actually totally below the plane there as it is. So here it's a little lower, we record, and then when we go back here, you see there's a small 1. Blue view that appeared, so that means there's a little update to do, so there's a right button on it. You can click Recompute Object. Here he calculates a small blow, and boom, it gets bigger, so that's magic. You have your assembly with you. The standard elements you will buy for your project, you put them in after you open. Position it a bit like you think if it doesn't play, and well, you can move it in different directions until it plays. until it's a little bit like that. You like it right now. We dropped it and we see it's a little consistent, so it's perfect. We record it. Here we're going to do a little bit of a small passage for the encoder. So here what we're doing, we're actually going to rely on our shape binder. We're going to use it as an external element of geometry in the sketch. Here it creates this reference point. Here we just come to create a circle that's going to be used to drill, so I'm not going to give it a diameter. When I build 3D enclosures like that, I do this a little bit to the feeling eye, and I see that I'm more. Having a little margin like that, I'm a little wider than the diameter of my encoder. Here's hot. And then we use the pocket tool, and then it dug us the volume. So here we are creating our re. So now what we're missing is this is the attachment elements to come screw our small electronic circuits. Because here we put all this on one side, so I didn't leave much thickness in reality. So we're going to see how we do this. That's not the best example I'm showing you here. It's really an illustration example. So typically, for the encoder, we're going to be able to say we're coming to put on plots. The location of the screw passage is there, so we do it like that. We're going to say they're equal. It collides with nothing, we give them a small diameter. And as we're coming to put a threaded insert there in the middle, we don't have to say we're putting on a screwdriver. So we're going to put a second circle. There you go. There I am too. They say they're equal here. There you go. Then, they're a redundant constraint. In millimeter, I would say 2.5. And there was an automatic constraint that I didn't want before. It's going to be that equality constraint right now, I guess. So there. The blow, now it's released. So I've had it done again and again. It's kind of painful. Because in the sketcher, there is a small helper that is actually very practical. What got me there is that you see that it automatically forced me my diameter to the diameter of the external geometry that I used. What I didn't necessarily want. So then you have the best time, in fact, to completely stand aside, completely outside. There you go. Here I will also delete the wrong thing. So here we are against equality. These two diameters are forced inequality. And now we're going to set that diameter to 2.5 mm. There you go. That's exactly what I wanted. A small extrusion. There you go. That's where we're in 3 direct. So you can say how far you have to go. To the face, there. Then we'll be able to come and stare at our little one, our little electronic circuit there, directly on these little plots. There you go. All perfect. Simple. The Raspberry Pico. We see it's not very smart to take that surface as a reference because there's the connector there. So we have to leave a little bit of margin. Actually, we're just going to put it in the other direction. It'll be a lot smarter. So we're going to take this back. There you go. Here, we remove this constraint. We're going to turn it over. Like this. Hop, hop, hop. We're going to put it down a little bit like that. There you go. It's a little smarter to do that like that. We're going to record this. We're once again giving up our shape builder. There you go. Much better. There you go. Much better. So that's how it is. It makes you realize what we're doing. So here in the same way, I'm not going to do it here because it's putting the video away in a useless way. You can put your small screw fasteners there for the other screw passages for these small printed circuits there. And then here you are sure that everything is consistent with what you use. There, to finish my box to make a little pretty. I'm actually going to put a little net on him, a little ray in the 4 corners. I'm not with the right workshop, so it's not going to be okay. Turning by design. And then we put a ray. 5 mm. 5, 6, 10 mm. Yeah, that's pretty good. There you go. So that's your little face right there. It doesn't look bad. So if we want to make an outer wall now, we can use another one. Once the additive pipe function to pull a wall outside following the contour of our room. So how are we going to do this? We're just going to create a sketch. We're going to base it on that face. We're going to take this element here a reference. We're doing a little rectangle here. So now we have our FreeCAD 1. New feature that allows you to enter dimensions directly is very useful. The way we want it to be a little solid. So 3 mm thick. And then we're going to do the case with 25 mm in height here. So it starts there when we've got the beam. So we're going to reposition our sketch so it starts here. How do you do that? You go directly here in attachment position, and then you can actually move your sketch relative to the reference element you used. So the reference is this face here. So net face 7. We can see it here directly in the software. And then we move 10 mm, so we start here. There, and now to do the outside of it, we're going to use this function there. So we're actually going to extrude sketch 3 along a profile that we're going to select. So now we're going to manually select it. We're going to do add edge. So that's it, magic. So here you have to do add edge again every time. Add edge. Last ray. And there you go. We made a nice little box, based in fact on external elements of geometry. So that's really a typical case too. A little more complex though. Now we can add a little chamfer there so it's pretty. The same here around. So we're going to select the 4 stops. Control. Then you will notice that when you are in the 3D, actually to select the different elements, you use the Control key, and instead when you are in the SketchUp, you use Shift key, so uppercase. There you go. Chamfer. And there you go. That's so pretty. Alright. All beautiful. And you have your shape builder, which is the ghost of assembly of your parts, which allows you to understand in fact where the external elements are. You do not have to display it, so you really see the piece you've created. But working like that, you're sure when you're going. Creating your play and wanting to use it will be consistent. It's gonna work because if you try to do everything by hand, measure with your foot, backstage your setting, and everything. Yes, if you are very attentive and very careful, you will be able to do so. But today we're working more like this. Now we have to work with threads, so you take the thread and you use it to create your new constructions. So this is the second really typical, very common workflow. To build a room, so if we repeat there, we created a housing. It will allow it to integrate 3 small electronic plates to make a prototype. So we actually rely on the threads of our purchased components. Which have been supplied by the manufacturer or a generous manufacturer, which makes it available on a GrabCAD exchange platform. And at first we actually make a positioning of our external elements. According to our technical and aesthetic choices. And once we did that, so we're going to be able to create our room like the individual room. Exactly the same, so a new file, a body. But at the beginning, in fact, in addition to the marker, we create a shape under, which is based on external elements. So in this way, we know where the elements are to be integrated, in fact. What we need to take into account, in fact, when building our room. And we can actually use these elements for our construction. So, to position sketches, use them as external elements. So that's what we did here. So after the process, it's the same as the room alone. So it's a sketch, a volume creation, material removals, screw passage, anything you want. And always at the end, the chamfers, the spokes for the sketch. So that's the second case. So I'd say it's the middle room. So here it was already a kind of mini project, in fact. But it's something quite common. So I hope that through this tuto I'll have you a little bit titillated. And then learn something about how to use FreeCAD smartly. To do your little auto constructions, your little DEAGE, in which you integrate parts, external elements. There you go. So if you're interested, put a little emoji Grinch in the comments. I like this character, and don't forget to subscribe to the channel, to like, to share, to comment. Share your feedback with me. I'm always curious to see how you perceive my content, and also make suggestions for content that might interest you. It can give me ideas. Thank you in advance. Thank you.